And our final thing for today is going to be on paper 1, November 2021. I just couldn't copy this down because it's a lot of things. So it says the roots of the equation are x equals to minus n plus or minus n squared minus 4mp all over 2m, where m, n, and p are positive real numbers. The m, n, and p are in that order form a geometric sequence. So n, m, and p. So m will be the first, n will be the second, and p will be the third. Prove that x is a non-real number. So yeah, so I'm gonna go back and forth between the two tabs. But yeah, so they say prove that x is a non-real number. So what are non-real numbers? Non-real numbers, you can think of, I mean, I would say the imaginary numbers, but I don't think you guys know what imaginary numbers are. But essentially the stuff like when, if a is a positive integer, so not even a positive, let's say a is an element of a natural number, not even a whole number, because a whole number includes 0. So if a is 0, then minus 0 is 0. But let's say a is a positive integer or a natural number, then this root is non-real. When you get to higher levels, you will then have this root be ai, where I equals to the root of minus 1. So I is a non-real number, but I squared would be a real number because I squared would be minus 1. So, but forget about that. Let's just focus on this for a minute. So we have to prove somehow that the root of x is minus. It has a minus in it. And since they say that all the numbers m, n, and p are positive integers, m, n, m, and p are positive integers, so they are also elements of natural numbers, and it looks like a matrix. The elements of a natural number, or positive integers. I don't like using positive integers because 0 is kind of a positive integer, but 0 could be negative and positive and still be 0. So I like saying natural numbers. Natural numbers, 0. Integers are written with z, right? This, yeah. So since we know that n, m, and p are elements of a positive integer, if we get that the root of the roots of x have a minus in them, we will get the answer. So this is a more level 4 question. It's fine if you skip it. I wouldn't blame you. I wouldn't blame you. But they also say something that is very interesting. They say n, m, and p in that order form a geometric sequence. So n, m, n, and p, right? Yeah, m, n, and p form a geometric sequence. So a couple of videos, we know what a geometric sequence is. It's that r equals to n over m, which equals to p over n. Interesting. This is a very interesting thing. We know this is the thing with geometric sequences. It's the geometric sequence goes ar squared, etc. So we know that r would be ar over a, which equals to ar squared over ar, which is true, they're all equal to r. So that is where this comes from. Remember that this is the how like the geometric sequence is. Of course, that TNs, you guys will know how TN works. It's ARN or ARN minus 1, or however you prefer to write your TN. So with all this information, we kind of know what we need to do. We need to prove that the roots of x have a I don't know, the roots of x have a negative integer or negative on its natural number, where a is an element of a natural number. We have to, and to do this process, we have to use elements of or fundamentals of geometric sequences to get the answer right there. So yeah, starting all the information you have. You know that M and P form a geometric sequence, so this will be AR squared, blah blah blah. And we're also given additional information that x equals to what is that? Minus n plus or minus root of n squared minus 4mp all over 2m. 2m. I mean, you immediately recognize this as the same as the quadratic formula and stuff. It's fine. It's fine. So, how do you prove that they're non-real? How do you prove that they're non-real? We said we need to prove this, so we need only this part to prove this. So we need to prove that n squared minus 4mp gives us a negative integer. We have to prove that. How do we prove that? Okay, we know that these are geometric sequences, and we know that in geometric sequences r equals to ar over a, which equals to ar squared over ar. R will then equal to n over m, which equals to p over n. Losing the r, of course, we don't need this part. We have this, right? And very conveniently, if we cross multiply, we're gonna get, or whatever you guys call it, we're gonna get n squared equals to mp. Boom! We have this and we have that. So we can replace m squared with mp, or we can replace mp with n squared. But let's replace n squared with mp because we already have it as the subject of a formula. So we're gonna have mp minus 4mp, which is minus 3mp. This is the golden ratio there. So since we know that m and p are all m and p are elements of natural numbers or positive integers, there is no way that we could multiply this and get a positive integer. Thus, we'll always get a negative integer, and we'll then have the root of that be a negative integer. Having the root of x have a negative integer shows that the roots of x are then non-real. It's a really nice thing to think about. 4 marks. That wasn't that long. It took us 10 minutes. Oh my god, that was long. It's really interesting to think about. Yeah, you can also do it reverse. You have n squared minus 4n squared, which will be minus 3n squared. So that's a nice thing to think about. So yeah, hope you guys enjoyed that short video. This is a level 4 question. You have to know not only solving for x, but geometric sequences and all those things. Usually questions that put all those elements together are called level 4 questions, and uh, students with or who don't students usually leave them, which is totally fine. If you were I mean, like, this is so much English, and yeah, this is the roots of the equation are and the sequence on the as I would suggest you skip it and then do it later, or if you can do it then, if you think you can do it. um it really wants you to be more relaxed because it's so many words. It was kind of hard for me to keep up with the words. Every time I see words, I'm like, oh my god, there's so many words. Yeah, otherwise, yeah. We can continue doing this paper if you guys want. Um, Really interesting paper. Or we can do Gaussian integrals. Um, so this is like higher math. Or we can do an Olympics one. But if you guys want me to continue with some of the questions here, I will be totally happy to do it for you guys. The really easy, really nice. But don't. Oh, this question 7 looks really nice. Don't beat yourself up if you don't understand in the first time. Um, like, we all struggle. There's always like learning something new is harder than learning something you already know. So yeah, thank you guys, and enjoy your weekend if you enjoy your everything. Bye.